Hello, everyone, and welcome to Streaming Fast and Slow, how to successfully be an early adopter of stream processing at your company with a particular focus on integration, operations, and analytics. So my name is Kato Schur, and I'm a developer advocate. I represent the US region for Vivarica, the creators of Apache Flink. I used to be a software engineer for a data analytics company, and I'm a huge nerd for anything stream processing and data analytics. I live in Portland, Oregon, and I have a variety of hobbies, including woodworking, dance, and running. I come to Beam from the angle of Apache Flink, which I first started working with in 2017. I'm here because of the experiences that I had as an early adopter of stream processing at a previous company for a top-tier project. And I want to talk about what I learned about successfully integrating a new streaming application into a complex non-streaming ecosystem on a tight timeline. This talk will be very applicable to anyone that wants to use Beam with another stream processing framework like Flink, but it'll also be applicable to using Beam with almost any of those. So regardless if it's Flink, Spark, etc. And I'll start with a little bit of background, our use case and some of the challenges that we had. Next, I'll go over integrating stream processing into a non-stream processing ecosystem, which is the fun part where a lot of the people problems and the tech problems go most hand in hand. Then I'll go over what we learned about our operations. And lastly, I'll cover analytics, focusing on monitoring and alerting. So before I go into the background, it's good to set a couple definitions. I'm referring to my team here as early adopters, but that can mean different things to different people. In this context, I'm mainly referring to being the first one or team at your company that's building a stream processing app, particularly for production use. This is also a good time to mention that unfortunately the project that I'm talking about here is actually proprietary, so not open source. So feel free to still reach out to me about it, but I may not be able to go into everything. So on a high level, this project was to create a new data pipeline to organize, track, and store customer usage information in a way that was highly secure and could be queried for in real time by various different people. So a perfect use case for Beam. On the logistical side, this was a top-tier system that would need to interact with every product and a variety of other apps and services, particularly those involving accounts or subscriptions. In terms of people and process, there's the familiar story of a tight timeline and a small team, but this had the additional complication of being at a company that was completely new to the framework we had selected and was relatively new to stream processing entirely. So this is an example of what customers would see on their end. This represents usage for their account with subscriptions to various products, and this actually only shows about half. Okay, so it needs to be accurate because it's closely tied to billing, and it would need to be accessible in near real time. As for throughput, this shows just one customer who would have data for maybe 7+ products, and some have several units of measurement, different data retention specifications, and subscription tiers. Add the fact that there's a lot of metadata about a lot of this, and then multiply that by a huge number of customers. So we needed a system that could handle this rapid growth and sustainably handle it for the foreseeable future. So luckily, there's a lot of frameworks out there that can solve for a lot of these challenges and in really powerful and impressive ways, like Flink and Beam, which is why we're here. Okay, so problem solved, right? And in the end, yes, absolutely yes. But in order for us to even use the features that would end up solving all of our complicated problems, we needed to integrate this new application into that large and complex pre-existing system that may not be prepared at all for that impact of such a powerful, fast stream processing framework. So we knew that we'd have to compensate for certain operational costs, like storage capacity for storing state, since we picked Apache Flink, and storing save points. However, we may not have been prepared for how much we had to factor in the use cases of our dependent and upstream applications into the program design and configuration. So why streaming fast and slow? So first I want to talk about speed. One of the main reasons people love the most popular stream processing frameworks, like why we're here, is because they optimize for that low latency and can consume and process data obscenely fast. The fact that Apache Flink and Spark can both process tens of millions of records per second and Beam can go about as fast as any of these frameworks is, of course, awesome. So these frameworks can enable you to stream data at top speed. Awesome. But this means that the first problem we encountered was, as the engineer or engineering team, how do you keep up with something that's that fast? So to me, it was kind of like training for a big sporting event, like a marathon for the first time. So I had a great example of this happen to me. I actually just found out like 10 minutes ago that it was literally this day last year. So this is very appropriate. So in the before times when we could go out with other people, I mentioned one of my hobbies is running. And last year on this day, I signed up for a multiple day relay race with thousands of other runners across half the state of Oregon. I also signed up late with about 2 weeks to train. So this race was like nothing I'd ever done before. I needed to run on multiple different types of terrain, different temperatures, different times of day. I'd had to navigate places I'd never been and coordinate with lots of other people running before and after me. And I would have to be able to integrate well with many streams of runners running alongside me. So I had to come to terms with the fact that just because I'm a runner does not mean I'm prepared for this special kind of race. Like how just because my team was full of very experienced engineers didn't mean we were automatically prepared for jumping in and keeping up with a new super fast stream processing framework at that kind of scale. It also didn't mean that we couldn't do it, or even that we couldn't do it on that super short timeline. It just meant we had to be extra aware of some of these extra requirements that we needed in order to keep up. So in both scenarios, it wasn't just about understanding the technical concepts of the new framework or being a skilled engineer or athlete, but it was about the work involved around being creative on that impact that you have on that surrounding system and using this to streamline some very preventable hurdles in the integration process. For the marathon race, I had to completely reevaluate how I trained. I had to integrate the aspects of running that I was familiar with into a large, complicated event that involved lots of other runners running in parallel to us. I would need to run in a way that could be made compatible with the processes and meet the standards of the event system as a whole. My entire team had to be aware of the running patterns and understand how to address issues that came up with teams that were running upstream of us. I had to invest in completely new running gear and resources. Old gear that may have held up okay while I was running in small batches may not be able to hold up to this new situation. And while you're running in small batches, when you're able to stop, check progress, and readjust, there were certain resources that in running I could just skip if inconvenient, like with engineering as well. But of course, if you're running anything continuously, you have to figure out ways to check your progress and readjust while you're still running. So also, even if that old gear did miraculously hold up for a seemingly endless stream of running, is it worth it to have it just merely hold up? Or is it worth investing in resources that you feel confident can scale with you and that can actually keep up with that full potential for power and speed? Additionally, in this analogy, we were running through uncharted territory with no cell phone reception, as in no existing way to track our progress for that area. So we need to reevaluate how we monitored our runners' health and performance and how and when we would alert on any issues like a stop in progress. So in this analogy, maybe you're a very experienced engineer. Maybe you've even worked with very powerful, fast, very athletic stream processing frameworks before. Maybe your applications are very healthy and have been in very good shape enough to accommodate other impressive changes in new technologies. And this was the case for the engineering team that I was on. However, just like the relay race, we found that in order to keep up with that speed, like you'd have with Beamer Flink, and especially when integrating our new service into something that is so large and complex, we still had to really slow down and make some serious adjustments in how we normally went about that process. We had to be particularly careful in this case about how we impacted the tech ecosystem around us. Could the non-streaming sources upstream of us and downstream, and our apps and our sink, where the data ends up, in our case, an internal data store, be able to handle that continuous stream? And some of these are obvious questions, but we found that ecosystem and the teams around us, being able to troubleshoot that was a lot more complicated, especially if they were not familiar with stream processing or specific Beam or Flink concepts. We also had to drastically readjust our gear, our resources like our container configurations, memory allocation, etc. And this one also probably seems obvious since allocating these are usually part of the basic getting started steps for building any new streaming application. But of course, you want to set yourself up to be able to continue to scale. But we had to be extra clear with stakeholders and others who may be in charge of approving the resources that you've requested, especially if they're not familiar with stream processing, that we would need more than what's required for a single isolated streaming application, but we'd also need ownership of these resources because we were going to be impacting them in a completely different way than we had been before. And finally, we were in uncharted territory. Since we couldn't just stop and examine a well-defined batch of data once it had already been processed, or wait until the records were successfully written out to our data store at the end of the pipeline, we would need to find better ways of looking inside that pipeline to monitor that throughput, latency, and any unexpected potential stops or spikes before they became an issue. And honestly, this would have been less of an issue, particularly if you're using Beam, except that we had so many teams writing to our pipeline, and a lot of these teams were actually writing and processing their data in completely different ways from each other. And this wasn't just more work because of that increase in technical complexity, because those are predictable. But in our case, this was also had the unpredictable complexity of dealing with those teams on a personal level, which brings us to integration. So as for integrating that into the technical ecosystem, some of the best features for stream processing for your team we found can also be the biggest drawbacks for a lot of the teams that interact with you, which is just ouch. So firstly, if you're unifying streams of data owned by different teams, you may find that some teams that you thought all treated their data the same don't. And honestly, we found it was just best to assume that each team that we're consuming from may be treating their data differently from the next, which I'll go into more later. In our case, we had to be really specific about our needs for aggregating the data and exactly what that needed to look like. And not all teams were able to implement the logic fast enough to adhere to that schema before our launch. So we had to factor that into the time and design, and we ended up creating an additional Flink application that provided aggregation calculations on the data for those particular streams coming in that were not able to do it. And I want to really emphasize that for some of the biggest hurdles that we had, the best resolutions came from us as engineers, optimizing for understanding our impact on other teams' domains and letting that data inform our architecture and design process. So otherwise, you could end up at the last minute with data in a form that is completely unusable to you. You could end up with no one wanting to take ownership of monitoring and consequently insufficient insight into your data, or worse, insufficient alerts. So of course, if you're carrying the pager for that is not so fun. So this leads to some other related issues with being an early adopter. And I want to talk about creating and automating community within your company for that new technology that you're adopting. So this was actually one of the best ways that we found to mitigate some of the common roadblocks that we found for being early stream processing adopters. Okay, so we're impacting other teams in ways that we had not before. We're also using shared resources like AWS buckets and internal container and deployment tools in a way that they had never been used before either. So this meant that we needed to understand other teams' applications better than we normally have to, but it also meant that other teams, leaders, architects, etc., very suddenly had to be familiar with our monitoring. And they had to be familiar with at least some basic stream processing, and in our case, Flink, in other cases, Beam concepts, so they could understand our monitoring, even as basic as just understanding simple terms. Okay, so what do I mean by automating an internal community? So basically, if we addressed every inter-team related issue as it came up, for stream processing and with that many integration points and just how much more complex those integration points get, this would be an incredibly long and painful process, and it would keep us from the fun part of our engineering work, which no one wants. No one wants to be kept away from that. So we found the heart of most of these issues were actually the same. Engineers having to repeatedly advocate for or explain very basic stream or beam concepts. So on the plus side, keeping things dry, this meant that we could easily automate resolution for these issues and make a virtuous cycle of information sharing through, firstly, creating a safe space for others to experiment with the new streaming technology that we're adopting, as well as providing interactive documentation and, of course, a good detailed map. So this is where the analogy gets a little too literal, because my running team were also coworkers, so we use the same internal tools, and both sets actually ended up making blog posts that had information for anyone that wanted to train like the running team or create their own Flink cluster and how to integrate that with internal tools. We also had a glossary for both of these, and it enabled people to be much more interactive with it. So this was super simple, super effective, and sharing these posts saved us a huge amount of time and having to explain what the heck we were working on in both cases. And as for supporting experimentation, both for the launch of the marathon race and for our new streaming application, my team in both situations, all we did was created an accessible chat room to support people who are experimenting with, to get help with what was going to be very new for them. So in both cases, people could ask each other questions about what resources, progress monitoring tools they used, and commiserate with each other for a failed experiment and congratulate each other for how well their sessions went. And I couldn't share the internal work Slack here, so here's a screenshot from the Slack space for the running team. So just replace elevation gain with messages per second, And you could basically swap these two out for each other. So thirdly, always take a map. So in both scenarios, it wasn't just about having a map of the pathway from start to finish, but it was essential that we clarify those integration points along the way so that teams could quickly assess where they were and who they were going to impact, especially in case of emergency. So with each of these, the more detailed each iteration of our map was, the more other teams who interacted with us were able to become more and more self-sufficient. So as I said previously, with automating that community, it's something that you no longer have to expend as much energy in, but you can also end up relying on them too, if you create that virtuous cycle fast enough. So another essential map that we used for both cases was an incident flowchart. So being able to triage situations. If you get lost in the woods and end up running in a circle, which did happen to someone, or your Flink application stops and instead of restarting successfully also begins to cycle for minutes on end, both of these are scary things. So in both cases, these incident flowcharts were kept ridiculously simple because that's exactly what you need if you get lost at 3 in the morning, either way. Okay, so this brings us to operations. So most people here probably have a good idea of some of the main operational drawbacks and risks of Beam and other compatible stream processing frameworks, like having additional storage needs. So particularly if you're using Beam with frameworks like Flink, where you might be storing things like save points in a very different way than you might be storing other elements like your state or checkpoints. So most well-architected stream processing frameworks, they have some features and workarounds to make this a lot easier. We even planned ahead for this, making sure that we could integrate really well with internal tools that we'd be using like Mesos and Zookeeper. However, because if you're in a situation like we were in, where you're at a very large company, where a lot of operations are separated into specialized teams, you may come across some similar issues with the fact that even if the tools are compatible, it doesn't mean that they're configured in a way that's going to really be helpful to you. So for us, it meant that we had very little control over reconfiguring them as well. And especially since it's a shared resource, this reconfiguration could be a very slow process and involve a lot of very unrelated teams as well, which can make it even more slow because they may not really be invested in wanting to do that with you. So internal deployment tools are probably the most common example of this, which is something that you can find a workaround for. In our case, we had a manually uploaded script, which we wrote a hook for that we were able to use. So yeah, which brings us to analytics. Okay, so with that running analogy, it's important to make sure that monitoring is well coordinated between teams and other stakeholders. In the running scenario, stakeholders could be the rest of your team who's ahead or behind you, or your family who's following your progress on a running app that's streaming your GPS signal to them in real time. During the relay race, my stakeholders, which were my family, were remotely following my progress on an app. And when my progress stopped and disappeared at 3 in the morning with no way of alerting them because of cell phone reception, but they didn't know that, those were some very unhappy stakeholders. And none of us want unhappy stakeholders. So fortunately, although my team learned that we needed better monitoring for progress within the running routes, it did really help that we knew what normal pace was for each runner. This gave them a reasonable threshold to know when to alert if a certain duration of time had passed without seeing a runner exit the pipeline. So luckily, in the engineering scenario, we actually had several features to compensate for this. In our case, we also included creating a unique field to key data on just for this particular pipeline. So here, stakeholders often ended up being the teams that own the application upstream or downstream of us, in addition to traditional stakeholders. So as I said earlier, we found that we had to be much more familiar, particularly with those upstream applications, than we needed to be previously, as well as understanding their alerting and what their normal looks like. But honestly, for ensuring that they understood our monitoring, most of this was less than 45 minutes of relabeling our dashboards, just so that it could be more clear for them. So quickly, back to the running analogy. In the multi-day relay race, issues like unexpected stops in progress could signify a serious issue. So you had to be able to monitor and alert on this. And knowing what your normal like is incredibly, incredibly important. So I'm running out of time, so I'm going to go through the last part a little bit quickly. But basically, knowing what that normal is, so you know if you have anything that's actually normal, so we found out here, the spike from 9:10 to 9:15 for our Kafka lag was actually normal for 3 of our streams coming in that we were consuming, and it was actually abnormal for our others. So this is incredibly important, but it's also important to know what your gotchas are. So if you're working around a predictable spike, it's easy to be able to just let that go, unless you have something like maybe some of the teams are working in one time zone and some are working in a different time zone, and understanding if that normal is going to change. So super important. And in the end, I love working with these powerful stream processing frameworks because of the incredibly high performance like this. Frameworks like Beam and compatible frameworks like Apache Flink have these amazing features that can, and for us really honestly did, solve a lot of these big complicated problems. However, keeping up with something that's this fast and powerful can really take some creative readjustments to integrate into a pre-existing non-streaming system. But take it from me, when you speed through that finish line, it is totally worth it. And with that, thank you so much, everyone. I'm so happy to be here. And if you want to get a hold of me, feel free to reach out to me in Slack. Thanks.